Good morning students. Today we will discuss about origin of energy band formation in solids. Okay, now we will discuss how energy bands are formed in solids. Okay, now if I consider an isolated atom, means if I consider an single atom. So what happens in the atom? Electrons are tightly bound and it forms the discrete energy level. So it forms the discrete energy level. So if I take one atom, it forms the one discrete energy level. Okay, now if I take two atoms, so if I take two atoms, it forms two discrete energy levels. So it forms two discrete energy levels. So if atoms are close to each other, so if atoms are brought close to each other, what happens is these energy levels also overlap on each other. So if I consider one atom, it has one discrete energy level. If two atoms are brought close to each other, so what happens? The electron orbits interact with each other. So the combined system, it gives two energy levels, but these two energy levels will overlap on each other. Okay, so like this, if I consider n atoms, if I consider n atoms, so n atoms forms how many energy levels? N energy levels, n discrete energy levels. So if these atoms are brought close to each other, if these atoms are brought close to each other, these energy levels also will be close to each other. So they form n energy levels. So the width of these energy levels, the width of these energy levels, the width of this band depends on extent of overlapping. So see here, if the atoms are close to each other, what about the width of this band? This band, width of this band decreases because the energy levels will get closer. If atoms are separated, these energy levels also will get separated. So these energy levels, when they are close to each other, they looks like they form a band. So see here, if n energy levels are there, if n atoms are far away from each other, the energy levels also will be far from each other. If they are brought close to each other, these energy levels also will be brought close to each other. So there doesn't appear like energy levels. It appears like it is forming a band. It is forming like a band. So the width of the energy band depends on extent of overlapping. So if atoms are very closely packed together, the energy levels also will be very closely packed. These energy levels also will be very closed. So width of this band decreases. Okay. So if I go for a solid, the solid consists of many number of atoms. The solid consists of many number of atoms. Now, see here, if I consider sodium atom, what is the electronic configuration of sodium atom? 11. Its atomic number is 11. Its electronic configuration is 1s2, 2s2, 2p6, 3s1. This is the electronic configuration of sodium. Okay. Now 1s2, 2s2, 2p6. These we call it as inner electrons. These we call it as inner electrons. The important one is valency electron. So 3s1 is the valency electron. So if you give energy, what happens? This electron jumps from 3s level to 3p level. Okay. So like this, if I consider single sodium atom, this is the configuration. If I consider a solid, solid consists of many sodium atoms. So in many sodium atoms, what happens is all these inner electrons occupy inner band. All these inner electrons occupy inner band, which is of no importance. Inner band. Next, all these 3s orbitals of all sodium atoms overlap to form valency band. So the band which is occupied by valency electrons is called as valency band. All sodium atom 3s orbitals overlap. These energy levels overlap to form a bond. See here, one sodium 3s orbital, other sodium 3s orbital, other sodium 3s orbital, all these overlap, they form a band which is called as valency band. So what are filled in this valency band? Valency electrons. Next, all the uppermost orbitals, 3p orbitals, all 3p orbitals overlap to give conduction band. So if you don't give any temperature, conduction band is empty. Okay. Now we'll see this graphically. We'll represent this graphically. Okay. So see here, when we draw a graph, between interatomic spacing, interatomic spacing means the space between atoms, interatomic spacing, which is represented by R, and this is energy. Okay. Now inner electrons occupy inner bands. Inner electrons occupy inner bands, which is of not important for this one. Okay. Next, see here, what is the next orbital? So here next orbitals are, see here, these are 3s. For sodium it is 3s orbital. So these orbitals overlap to give valency band. Next one is higher one is 3p. So here these overlap to give conduction band. This overlap to give conduction band. Here VB means valency band. CB means conduction band. Okay. Now valency band is filled with valency electrons and conduction band is filled with, so at 0 Kelvin conduction band is empty. There is no electron in conduction band. Okay. Now, so see here, when the atoms are very close to each other. So see here, when the interatomic distance between atoms is very less, what happens? The valency band and conduction band overlap on each other. The valency band and conduction band overlap on each other. So here, this valency band and conduction band overlaps on each other. This we call it as conductors. These we call it as conductors. So there is no gap. Next, when interatomic spacing is increasing, so when we move little bit, when atoms becomes little bit farther, so see here there is a little bit of gap. See here there is a gap. This is the gap between valency band and conduction band. Very small gap between valency band and conduction band. These we call it as insulators. No, sorry. These we call it as semiconductors. Very small gap between valency band and conduction band, we call it as semiconductors. Next, large gap between valency band and conduction band, they are considered as insulators. The large gap between valency band and conduction band. So like this, solids are divided into three types. One is conductors, semiconductors and insulators. The gap between valency band and conduction band is called as forbidden energy gap. This we call it as forbidden energy gap, which is represented by Eg. So now what is valency band? The band which is occupied by valency electrons is called as valency band. So at T is equal to 0 Kelvin, at 0 temperature, it may be partially filled or it may be completely filled. What about conduction band? At T is equal to 0 Kelvin, conduction band is empty. When you give temperature, then only electron move from valency band to conduction band. But in case of conductors, these valency band and conduction band overlap with each other and electrons are free to move. So, depending on the forbidden band gap, solids are divided into conductors, semiconductors and insulators. So, this is about the origin of energy band formation in solids.